I am the content director for Physics Club in the 25-26 school year. So I know that I think AP Physics 1 has finished kinematics recently, so I think the next step from there is forces. So in this video, I'm going to be covering the basics of forces that you would need to know for AP Physics 1 right before you begin. So I think what we should probably go over first would be, what is a force? Well, a force can simply be noted as a push or a pull of any sort. So for example, if I have like a ball, we'll draw this ball, and then I push it with some force F, then it is, it's feeling the force of this push. I can also pull it. So say I have some rope here, then I can put my hands around it, and then I can, we'll just say that this is going with force F, okay? And these are like my arms, and it's my hand pulling on this rope. So this would be a pull, okay? And another thing to note is that force is a vector quantity. So the direction of the force does matter alongside with its magnitude. So for example, this right here, this left going force, or well, it's going rightwards, is positive. And then if I push like this, then this will be negative. So if they're identical, then do F minus F equals to 0. So there's no net force. So vectors are like forces are vectors, and this is a very important part to know. So the next part that I will be going over will be Newton's three laws, which would be basically what you need to know. So the first law is that if there is a net force of 0, so I'll just write this with this, F net equals to 0, then there is no change in velocity. So delta velocity is 0, or you could say motion is the same. I like to not say that an object will stay at rest because, I mean, if you're moving at some velocity, and there's no acceleration on it, you're going to stay at that velocity. So it's kind of like the motion of an object would stay at its same state if there's no net force applied on it. So for example, if I have this block and for some reason it's moving at 3 meters per second and it's doing it by itself, unless if I apply a force of F this way and a force of negative F this way, then the net force is equal to 0. So then it will continuously stay at 3 meters per second. Same thing if it was at rest. If it's at rest and say I push up at 5 meters per second and then I push down at negative 5 meters per second, it's going to stay at rest. Okay? Step two is force is equal to mass times acceleration. The actual like way to derive this equation is not super important. Newton did write it a bit differently, but this is a if you know moment, I guess. I would say it like that. So this is basically the thing, and the units that you would be using for force would be kilograms times meters per second squared, because we have mass, acceleration. This can also be written as a Newton. So this equation is very important for any of the mathematical things that you are going to do. Number three is for every force, there is an equal and opposite force backwards. So um, this mainly applies to like internal forces or interaction forces. So for example, say I have my hand, and this hand is a circle, and we push against this block with, say, um, some force F. Well, then the block is also technically going, I'm gonna feel the force of the block against my hand at also force F. Now the block can accelerate, but I will still feel that force. The reason that things accelerate is because the amount of force needed to make the move is different. Because if we go back to the F equals ma equation, then since mass and acceleration are directly inversal, then if you have some force, but it's a very heavy object, it's not going to accelerate much. But if it's a very light object, then it's going to accelerate a lot. So internal forces usually cancel out with each other, which is why you don't need to worry about, like, say, the particles inside of an object, like pushing up against each other, because they also cancel out. So that's why you can say that for every force, there is opposite and equal reaction. Or for every action, there's an opposite and equal reaction. So these are Newton's three laws. So if the net force on an object is equal to 0, then motion or its velocity is conserved. So there's not going to be no changes in velocity. Um, The equation of force is equal to mass times acceleration, and mass and acceleration are inversal to each other because we do, you know, m equals to F over A, or you can do the opposite as well. Number three, an object, um, every force has an opposite and equal reaction force to it. So I'm sure you've heard of these laws before, but the thing about them is that the way they're applied is quite different. At least the second one. The third one as well. The first one is also applied. That's usually more theoretical questions they ask you. So, I think the next step to go from here would probably be to learn about free body diagrams. So free body diagrams are very useful in modeling all the forces of an object. So every single force that is acting on an object, you would model in its free body diagram. So say we have some block A, okay? And A is, we'll just say that it's on like some platform here. So if we want to make a free body diagram of A, then the only force acting on this A, or there's actually two forces, I should say, is the force of gravity. So we denote this as Fg, or mg you can write that as, because g itself is the acceleration, if you remember from kinematics. So if you plugged in g into this F formula, you'd get mg. So usually they'll say like Fg or mg or some sort of notation like that. Um, and there's, since the block is not falling through the floor, there also has to be some other force. And this force is going to be called the normal force. Oops. So this normal force um, is equal to mg. It has to be equal to mg because, and also make sure to donate your forces as like this, because this is how you donate or notate vectors, I should say. So the reason that normal force must be equal to the force of gravity is because we see that the block is not like going upwards, nor is it going downwards. So if we were to do the calculations in which up is positive and down is negative, and we simply do, let's say that n equals to f1 and mg equals to f2, then f1 plus f2 is equal to 0. Then we have n minus mg because it's 0. So n must be equal to mg. And this works because, like I said, the block is not accelerating upwards or downwards. So the net force there would be 0. And it follows from Newton's first law. Um, so the force of gravity is usually going to be a very key force that you're going to need to know whenever you are drawing a free body diagram. And remember that for a free body diagram, the only forces you would draw in the free body diagram of an object would be the forces that are acting on the object. So for example, if I have, instead I have one block, I have two blocks here. And we'll say that these two blocks are colliding at this point here. Okay, and this is block A, and this is block B. I know my handwriting isn't the best, but I am speaking through it, so I hope you can understand it. And these videos are relatively supplementary to what you learn in class. So make sure to pay attention to class. So if you have these two blocks and they're interacting with each other, and let's just say that this block A hits it with some F force, um, and this block also hits it back with some force of negative 2F, okay? If I wanted to draw the free body diagram of, say, A, right, and we'll do that down here, then here's the forces that I would need to draw. So first force I would draw would be gravity, because every object has some gravity to it. Um, the other force I would draw would be the normal force. Since the block is not moving upwards, it's a purely horizontal thing. And make sure that when you're drawing free body diagrams, you pay attention to like the size of the arrows, because they are vectors, and whenever you draw vector arrows, they do denote magnitude. So try to make like normal force and gravitational force, I should write this as Fg instead, as symmetrical, or like not symmetrical, as I should say, but as equal in magnitude as possible. And since like I said earlier, in a free body diagram, you only have to draw the forces that are acting on an object, not the forces that it exerts, then I'd be drawing a force of negative 2F this way. So this would be the free body diagram of A. Now, what if I want to draw for B? Well, B is actually pretty similar. Oh, this is not a good looking box. Hold on, let me fix this. Okay, this looks better. So be like I said before, we would have the force Fg and the normal force. These two are meant to be the same. So if they don't look the same, that's my bad. But normal force and gravity should be the same. The other force I would draw would be this force F like we had here, because this is what's being exerted onto the block by the other block. So the one way to notate this is we can say that the force of block A on block B. So that's usually the notation for it. So the last thing I'm going to be covering this video is probably just going to be explaining what a normal force actually is, because although like kind of explained it earlier, I think it'd be better if I explain it deeper. So a normal force, whenever something means like normal, it usually means perpendicular. So you can think of a normal force as the perpendicular force to the surface. And perpendicular means that like it's a line and it creates an angle of 90 at the bottom. So for example, if I have this and then I make this block again, and we have this gravitational force downwards, and then some normal force upwards, then I need to start notating this, let's do this. But um if I drew this line complete down, then you'd see like a right angle here, which would mean it's perpendicular. So it always has to be perpendicular to the surface that it's on. Surface is not like a straight line like this, or it's a straight line, but it's like tilted, or at an incline like this. The normal force is still going to be perpendicular to that surface. So if you do this, then it'll be perpendicular like that. So that is kind of how you would symbolize like the normal force. It's always going to be the perpendicular force. Um, and that's all you need to know because you will learn about inclined planes probably next week. So that is essentially it for this first part of gravity. So I went over a force, like what it is, its laws, the fact that it's a vector, and then free body diagram. So this is like the most basic part of forces, the most fundamental part that you're always going to use in every single problem, basically. So if you enjoyed it, make sure to like and subscribe to and go to the interest meetings for physics club and go to the general meetings because they're really fun. I'm going to be uploading a bunch of C videos as well. I think Mia might be doing the AP Physics 2 videos. Um, and probably a lot of the modern lectures are also going to be on here as well. So if you really like this video, make sure to like, go to the Physics Club meetings. And if you see me in school, you can say hi or something. But that's about it for this video on forces.